Everything's happy, content. 11, you got it. Ooh, okay, that's a good one. So number 11. Okay, so the biggest error that takes place on this type of problem, and this has to do with parentheses as well. So many students want to go 1 minus 2 first. And I understand if there was nothing else there, 1 minus 2 all day long. But this negative 2 is being attached to this absolute value, which means I cannot go 1 minus 2 first. So I want to get rid of that 1. So I can't combine that 1. That 1 right there cannot be combined. So what I want to do is I'm going to go ahead and subtract that 1. And that's tough to look at because it just looks silly. Negative 15 minus 1, I believe, is negative 16. Okay, so that's the first place that people would make a mistake on a problem. They'd say, oh, I'm gonna combine those together. No, because this negative 2 is being attached to that. Now, the second big error that takes place with inequalities, and here's the thing, it will work on some of these problems. But a lot of people want to say, oh, I'm going to treat the absolute value like parentheses, and I'm just going to distribute over. It will sometimes work, but I don't like sometimes. I like when it always works. Okay? So do not distribute that negative 2 over the parentheses. Don't do it, don't do it, don't do it. Okay? Instead, move it over to the other side. So I'm going to divide each side by the negative 2. Those cancel. Then I'm left with the absolute value of 5 minus 2x. Negative over negative is positive. 16 over 2 is 8. So let me just pause there. There was an awful lot of places where students can make errors. The first one is they think that I should just go 1 subtract 2 and go from there. Yeah.
You subtract 2.
Oh, I didn't. I divided it. Oh, divided. And then the second big error that can take place on these problems is people want to distribute over absolute value, and that's a real, just trust me, it's not going to always work. And I would hate for you to miss something in future math classes because you decided, oh, Stirrup said always distribute over, it's always going to work. No, it doesn't always work. So I'm trying to pull back on the reins saying, just please realize, I don't want to show you a concept that won't always work. Okay, especially for future. That's why I get rid of it. I don't distribute it over the parentheses. Now I can break this into 2 problems. So I'm going to break this into, this is the first problem. All the signs are the same, except I don't have an absolute value sign. And then I want to change the sign on the side of the equal sign that has the less stuff on it. Okay? Now someone asked, what if I changed that to a negative 5 and that to a positive 2 and didn't change that sign? That technically would work as well. And that's actually the more correct way to do it. But as of right now, I think it's easier to say the sign that has the less stuff on it, change the sign on. Okay? All right, so does the work look okay so far? Is there any more I should do? All right, so I'm going to go ahead and subtract 5 from both sides on this one. So those cancel. So I get negative 2 equals 3. Divide each side by negative 2. And those are going to cancel. So x equals negative 3 over 2. Don't go and make it a decimal. Don't make it a mixed number, please. And then the second problem, same thing. I'm going to subtract 5 from both sides. Those cancel. I get that. Divide each side by negative 2. Negative over negative is positive. 13 over 2 will not reduce, so I just keep it as 13 over 2. Okay? Now, please realize, I'm not going and finding that critical value. That was something that I had talked about because I wanted to start understanding that there's some place on the number line that we're going to be halfway in between 2 points on an absolute value. Okay? So I'm not worried about the critical value. I'm just worried about, these two are my answers. If I take those answers, plug them back in, they would create a true situation. Okay? Anything else off the homework you'd like to hit? Yeah. 8? Sure. Okay, this is exactly like the last one. A lot of people want to say, oh, let's go 12 minus 2 and get 10. No, don't do that. This negative 2 is attached to the absolute value, so I can't just go and combine. This would be like saying 12 minus 2x. Okay, I can't combine those together by adding and subtracting. Okay, so I want to make sure I move that 12 first. Let's get that moved. Okay, so I'm going to subtract 12. Those cancel. 0 subtract 12 is negative 12. Now, some people might say, oh, sweet, it's equal to a negative, therefore it's no solution. That only works if the absolute value is all by itself. I still have a negative 2 attached to that absolute value. So I'm going to divide each side by negative 2. Those cancel. Negative over negative, positive. 12 over 2, 6. Do you feel comfortable with the work I've shown? Okay. All right, break it into two problems. So I get 3x minus 6 equals 6. Okay, make it the exact same without the absolute values. And then 3x minus 6, change the sign on the side that has less stuff. Does that seem okay? I think we can solve both of those. I want to do this undo. All right, add 6, add 6. Those cancel. 3x equals 12. Divide by 3, divide by 3. So I get x equals 4. There's my first answer. Second one, add 6, add 6. Now, a lot of students, they kind of freak out going, wait, 3x is equal to 0. Yeah, that means what number times 3 equals 0? 0, right. So technically, you're dividing each side by 3, so 0 divided by 3 is just 0. So I have two answers. I have one that happens to be 4 and one that happens to be 0. Okay. Any other questions off last night's homework? We good? Everyone happy? All right, and just for as far as timing goes, let's say today's Tuesday, right? So 1 week from today, we will have the test on this unit, okay? But we have one last thing we're going to do. We're going to spend a couple days on it. We have some days of review, but we will get you prepared the best I can for this opportunity. We good? Cool. Would you turn to page 49 in your book? If you don't have or you're not a book with you, just come grab a sheet of paper up here. But go to page 49. 49. And I got to go back in time now and find where this is at. Okay, so we don't have that page. So now we have that page. So that looks like the very top one. Okay, so this looks a little silly. We have a star, a smiley face. I think it's a cloud, and a heart. What? Yeah, they're kind of goofy. All right, so this is kind of weird. So things that I would know is star and smiley face are being multiplied together. Cloud is being added to it, and somehow it's equal to a heart. Okay, all right. And I want to get smiley face all by itself. I want to get smiley face on one side all by itself. Okay. Oh, now we're going to have to test the abilities of art for stirrup. So I'm going to subtract cloud. Ew. That's, I'm sure some of you are much better artists than I am. I'm sorry. I need to go back and take art classes. All right, so these cancel. So I get star times smiley face equals heart minus cloud. Ew, jeez Louise, am I a bad artist. Okay, so I guess over in steps, we're try to get the smiley face alone. Okay, so star and smiley face are being multiplied together. So what undoes multiplication? Division. So I'm going to divide each side by star. Those cancel. So then I wind up with smiley face equals cloud over star. And I'm so sorry to subject you with my poor creative writing abilities or artistic abilities. Okay. Question so far. Now, this looks bad. I bet you, I really hope it gets better. I really hope it gets better. For some reason, I don't think I have any more stuff on the notes. Oh, I do. I have that. You know what? I want to skip this, and I want to skip this, and let's just get into dealing with X and Y again, rather than watching Stirrup struggle. Do you have that page? It's just on the backside, right? Okay. Now, I want you to do me a favor. If I make a step and you're like, where did that come from? Stop me. Okay? Deal? Y'all with me on that? So if I make a move, please stop me. Okay. So first thing I want to do, I'm just going to indicate, I want to get y by itself. Okay? So I want to get y equals. I want it all by itself. Okay? All right. First off, is it positive 2x or negative 2x that's up there on number 1? Positive 2x. So what undoes positive 2x? Negative 2x. Are you okay with me doing that? If I do that, it's going to clear it out on one side. I'm going to wind up with this. Now, hey, is that a positive 24 originally? So this is my answer. Now, why did I change the order of it? A lot of times in math, they like to have some letter equal if there's another letter and then the numbers. Okay? So that's all I did. I mean, I guess I could have an answer of y equals 24 minus 2x. That's totally fine as well. That's what's taking place there. Ooh. Questions? Straightforward? Yeah.
Why wouldn't you subtract the x from 24?
Oh, because this has an x attached to it, so it's not a like term. So it has to be a like term. So if it was just a 24 and a minus 2 all day long, but because the negative 2 has the x attached to it, we can't combine them by add or subtract. All right. So problem number 2. I see a denominator. Agreed? I mean, technically, I'm trying to get this by itself. I'm trying to get that y all by itself. Okay, but I have a denominator, so what should I do? What should I do? Remember we learned a weird skill to get rid of the F word fractions? Multiply everything by 2 over 1? Okay. All right, so I'm going to put a little note. Let's multiply all by 2 over 1 or just 2 because I don't always have to have a fraction. All right, so if I multiply this by 2 over 1, and this by 2, would you feel comfortable with that? So I have a 2 here on the 3. I have a 2 over 1 because it's a fraction. And I have a 2 times the 6. At least it's trying to look like a 2, but it's a poor excuse. All right. We good so far? So what I'm going to do is we're going to highlight as we come across. What is this going to give me? 6x. Agree? There's a plus sign, so I'm going to do this. What is this going to do? 2 over 1 times 1 over 2 times y. It's just y, because the 2's cancel. You have 1 on top, 1 on bottom. When you're multiplying fractions, you can reduce. So that's going to give me just y. Agree? And so here's the math that's taking place. 2 goes into 2 once and leaves us a 1. So 1 times y is just y. What does this give me? 12. Does that seem okay? So by us doing that, we cleared our fraction. We got rid of our fraction. Our fraction is gone. Okay, our fraction is gone. Yeah.
Would it always, like, all the time be 2 over 1 or 2?
Yeah, well, look, like if this is a 3, it'd be 3 over 1, or if this was a 1 over 7, it'd be 7 over 1 or 7.
So whatever number is below it.
Yeah.
Whatever.
Yeah, and if we had multiple, let's say we had like 2 denominators, one being 3 and one being, say, 10. 3 times 10 is 30, so I'd multiply everything by 30. Gotcha. Got a Valentine card. What'd you do? You can blame me if you need to. All right. Hey, friends, what are we trying to solve for on these problems? Y, as far as number 1 and number 2. Okay? So I want to get that y all by itself. So I want this to be by itself. So what should I do to get y equals everything else? Why is it subtract? You're absolutely right, but why is it subtract 6x? Yeah, and it's a positive 6x, so the opposite of that is going to be a minus 6x. So those cancel, so I get y equals negative 6x. Is that a positive or a negative 12? Positive. Done. Let's stop there. Let's stop right there. Okay? So, questions? So all I did is I just manipulated things around by adding, subtracting, multiplying, or dividing. Okay. Number 3. Obviously, we're not solving for y. There's no y in that problem, right? But it says solve for a. F equals ma. M and A are being multiplied together. Anytime you have 2 letters next to each other in math, or a number next to a letter, and there's nothing in between, it means they're being multiplied together. So M and A are being multiplied together. That actually is a physics equation. It means force equals mass times acceleration. Usually, you're using the acceleration of gravity, which is negative 9.821 meters per second squared, or negative 22 feet per second squared. But that's for science classes to teach you. And then mass, how much does something weigh? Could be in pounds, could be in kilograms, depending upon which your way to measure. All right, so I'm going to say that M, A are multiplied together. Does that seem okay? All right. So I want to get a by itself. So what do you think I should do to both sides to get the a alone? Go ahead.
Divide by n.
Yeah, I'm going to divide each side by m. So those cancel. So I get a equals f over m. A equals f over m. You buy it? Hey, question for you. Yes. Oh, look who just showed up. With a friend. Grab your stuff. You're going to be escorted down to your room. The closest restroom is right there. You came down the stairs with your friend. Yeah. Bye. Bye. Good thing we offer this class every year. All right, number 4. Solve for W. Do you think that's a 21 or do we think that's a 2L? I think it's a 2L. I think it's a 2L. So P equals 2 times L plus 2 times W. 2 times L plus 2 times W. So this is something that you might see in geometry. This is perimeter is equal 2 times the length plus 2 times the width. Length and width have to, this actually finds us the distance around a rectangle called the perimeter. But that's something for next year. But let's just take a look at it. It says we want to solve for W. Now I want to rewrite this because I'm going to make the L like a cursive looking L. Because I think if I were to see that problem right away, I'd be like, wait a minute. Is that 21? But I think it's supposed to be an L. So I just rewrote it. I haven't done any math. Is that okay? So I want to get rid of W. Or excuse me, I want to get W all by itself. I want to get W all alone. Thoughts? Ooh, someone said subtract 2L. Is that right? Yeah. Heard a second on it? Third? Why would we subtract 2L? How do you know to subtract it? Yeah, it's a positive. There's not a sign in front of it. So in math, that means it's got to be positive. So I'm going to subtract 2L. Those are gone now. P subtract 2L. Oops. P subtract 2L. Let's see, that canceled. P minus 2L equals what? What do I have left? 2W. Do I have to put a plus sign there? What letter am I trying to get it by itself? W? So that wants to be alone. How are 2 and W being held together? Multiplication. What undoes multiplication, my friends? Division. Good. So I'm going to divide this by 2. And I have a choice. I think I like this choice. I'm going to divide this whole side by 2. And I think I can keep it that way, and I'll be pretty happy about that. So these are going to cancel. So W is equal to P minus 2L all over 2. The problem is all done. So, now, this seems like an obscure kind of math. Okay? Like, why can't we just leave it alone? And I agree. As you progress further and further in math and further in science, you're going to find by solving for a letter, this will actually allow you to take letters that you solve for and plug them into different equations. Okay? We got Einstein's theory of relativity equation up there. We've all seen E equals mc squared. I have no idea what it means because actually I do know what it means. E stands for energy. What's energy? Well, how much it takes to move something. M, how much something weighs. C, the speed of light. What? And then we're going to take the speed of light, which is really fast, and we're going to square it. But that's a very famous equation, and it's used over and over and over again in science. And it's used, they manipulate that equation around to go into other equations. So if you have an equation and you have an m in an equation, you can modify E equals mc squared to plug E over c squared in for your m value. If you happen to know energy, or we know the speed of light.
What's the speed of light?
Speed of light, how I was looking at it, is the sunlight takes 8 minutes to get to Earth. The sun is roughly 93 million miles away from Earth, give or take a couple miles, depending on the sea.
93 million divided by 8, and you measure it per minute.
Yeah, and then you convert per minutes per hour. It's fast. It's real fast. Cool. We ready for it? Did I do okay on this one? Cool. What do you guys feel like doing? A lot? Whole bunch? Just some? Well, there's only 12 problems. Hey, so I want to remind you all, so we're going to do pages 51, 52. But I also want to remind you, on Schoology, under our class for CP Algebra 1, I have a folder. I got to remember what it is. I think it's a red folder. I changed the color because everything else was blue. So for CP Algebra 1, there is a red folder that says SLE, odd answers. So if you go into that folder, bless you, if you go into that folder, you have a whole bunch of links. So this is SLE 15, what we're working on. So if you were to go into the SLE 15 folder and you click on it, now sometimes it works if you click on Schoology, sometimes it'll be like, hey, this can't be open, so it says open in a new window. So if you go there, it looks like it's 3 minutes, 59 seconds it's all the answers that are odd. They're worked out. Okay? So I just give you that as a tool. So friends, you can go ahead and start on that. But I just wanted to remind you that this is also available for you, okay? And I'm going to stop recording, if that's okay with you.